Good morning, everyone, or afternoon, or evening, whenever you happen to be watching this. Hope you're having a fantastic day. Today, we're going to be talking about rates of change. This is going to be where the calculus we've been learning is applied to real life. I talked to a couple of people yesterday about what do you call it? When Newton was sitting there coming up with his laws of there's three physical laws. One of them was velocity being distance related to time, change in distance of change in time. Well, that all has to deal with rates of change. So there's two ideas we want to go back and cover really quickly. First one is average rate of change. If you'll remember, this one is your secant line, not the tangent line, but the actual secant line. And it's basically slope of a secant line, right? The average rate of change, you take your two y values and subtract them, take your two x values, subtract them, and you get a secant line. Versus the instantaneous rate of change. Now the instantaneous rate of change is your derivative with respect to x. Now the derivative, the instantaneous rate of change, happens when you have a limit at, that's an x, as x approaches 0. So if we were to take our rate of change, our secant, and take the limit of it, we would have what we call our derivative. Now, the average rate of change, this is going to be something we'll look into in just a second here. The instantaneous rate of change, though, that's going to be our derivative. That'll be where velocity comes from, and so on and so on. So a lot of vocabulary words thrown in here. If you've had physics before, these should be kind of old hat. If not, then welcome to it. So you have the first one here, which is rectilinear motion. It's motion moving along a line. A particle represents some object that is allowed to move in either direction along a straight line. A good example of that is a yo-yo. That's the traditional example of rectilinear motion is a yo-yo. Goes up and down. That's all it does. Something else would be like a train. It only follows tracks in either left or right. Trains don't go up and down, right? So that would be an example of rectilinear motion. So thinking about motion here, going one direction, it says assume that the displacement of an object at time t is given by this equation, 3t cubed, 40.5t squared plus 162t. And t is on 0 to 8. So here's your interval. It's happening for 8 seconds here. And it says to find the velocity, speed, and acceleration functions at time t. So looking into this first, it says speed. Now the difference between velocity and speed, if you've had physics already, you know this. If you haven't, you probably do by now. Speed is the absolute value of velocity, meaning it doesn't matter what direction it goes. Velocity is speed plus direction. Such as right would be positive, left would be negative, that kind of thing. Up would be positive, down would be negative. Speed is just how fast something is going. It doesn't matter about direction. So to start off here with the idea, we start with velocity. So velocity, v of t, right, that's going to be s prime. So I'm going to take the derivative of s. So we've got 3 times 3 is 9t squared. Minus 40.5 squared, or 40.5t squared, the derivative of that is going to be 2 times 40.5, which is 81t, and then plus 162. So that's your velocity function. It's the derivative of position, which was given to us up here. So speed then, speed is going to be the absolute value of velocity. Speed is the absolute value of velocity. Now, it's a pretty easy concept when you think about it because all you're doing is taking that same function and throwing absolute value signs around it. Right? So if speed is the absolute value of velocity, then you can just take your velocity function, throw some absolute values around it, and now you have speed. Remember what this is going to do, think back to your pre-cal days, what this is going to do is take anything that is below the x-axis and flip it up. So anything that comes below the x-axis is going to be flipped up above it. All right. And then finally here, acceleration is the derivative of velocity. So a of t, acceleration, and take the derivative of the velocity function. So 18t minus 81. And there's acceleration. So from deriving these three formulas at any time, all I would have to do is, if someone gave me a time, like 4 seconds, if they wanted to know position, I would plug it into S of t. And I could tell you it's at this position. They want to know velocity, plug it in here. They want to know speed, find the absolute value of it. So if it's negative, change it to positive. They want to know acceleration, plug 4 in for t. And you can find the speed, you can find the position, velocity, speed, and acceleration at any point on time t. So this is really useful. Honestly, I prefer physics to be taught calculus-based because everything is all interlinked with one another. You don't have to worry about a billion different formulas. Everything is linked together. All right? So number 2 says find the displacement of the object. Now displacement, awesome definition here. It's just where did it start versus where did it end. From the starting position to the ending position. Now if you look up at the information they gave us, let me scroll up here. If you look up at the information they gave us, where time is t, it's between 0 and 8. So this is going to be a relatively simple thing here. All it wants to do is figure out displacement. So displacement is the ending position versus the beginning position. So check this out here. This is your displacement. We can call that d. Why not? Displacement is going to be where you start, or where you ended up, S of 8, minus where you started, which is S of 0. We started at time 0. We ended up at time 8. And I got those figures from, again, right back up here. Started at time 0, ended up at time 8. So this is just finding the difference, right? It's all it is just finding the difference between those two. So if we plug an 8 in up here into our original function, there he is. So 3 times 8 cubed minus 40.5 times 8 squared plus 162 times 8. If we plug that in there, then we end up with 240. And then we're going to subtract. If we plug in a 0 into all those t's, that one's pretty simple. We get 0 minus 0 plus 0, which is all 0. So the displacement here is going to be 240. Now we don't know what. We don't know what that is measured in, but if we were given units back in the top, then we could throw those units in at this time. But since we don't have them, let's move on. And that's all displacement is. Start at the end, subtract where you started from, figure out how far you traveled. All right. A lot of awesome stuff on this one. I really like this lesson. Describing motion for an object. Describing motion for an object. First you've got, if velocity is greater than 0, the object is advancing, either up or right. Traditionally in physics, if you're going up, you're positive. If you're going right, you're positive. Think about your x values and your y values. If velocity is less than 0, then the object is retreating or going down or left. So if velocity is negative, then you're retreating. You're either reversing, you're going down, or you're going left. So it says, describe the motion for the object. So if you notice, where do these two things split? If you look at velocity, if it's greater than 0, it's advancing. If it's less than 0, it's retreating. Well, where does that split happen between advancing and retreating? Well, it happens at 0. So when your velocity is 0, that's when something is changing. So here's what we're going to do. We're going to take our original velocity function, which from the front was 9t squared minus 81t plus 162. We're going to take our original velocity function and let's find out where the split happens. Kind of like with a piecewise function. When you're trying to take a derivative of a piecewise, you got to figure out where the split happens. Same thing here. Let's throw a 0 in for velocity. Because I know that when it's greater than 0, it's going to be advancing. When it's less than 0, it's going to be retreating. So we set it equal to 0. Now on this side, we've got 9t squared minus 81t plus 162. Solving that for 0 requires first you take out a 9. Everything there is divisible by 9. Oops. So you get t squared minus 9t plus 18. Set it up, figure where it equals 0. So t squared minus 9t plus 18. If we wanted to factor that out, we got to find out where it equals 0, so let's factor it. We got t and t, and we need something that multiplies to a positive 18 and adds to a negative 9. So it multiplies to a positive and adds to a negative. That tells me both are going to be negative, and it's going to take a negative 6 and a negative 3, I think. All right. Solve for t, so you divide by 9, that just goes away, so we can just get rid of that. We have t minus 6 equals 0, and t minus 3 equals 0. Set it up, solve for t, you get t is 6 and 3. Now, if I had gotten something that was outside of my restricted domain, which is 0 to 8, if I got something outside of that, I would just throw that away. Okay, so if you think about this, your velocity function, you've got 3 here, you've got 6 here. Let's do a little sign analysis on that. This is v of t, obviously. Let's say we plug in a 0. That's going to be easy. If we plug in a 0 into velocity, we get 0 minus 0 plus 162, which is positive. So that tells me velocity is going to be up here. If I plug in something between 3 and 6, like let's say 4. Oops. Already done some of this before. 9 times 4 squared plus, minus 81 times 4 plus 162. Negative. I get a negative value, so it's going to go below the x-axis here. And then plug in something bigger than 6, for example, 7. Something like 7, right? And you get positive. Positive up here. So think about what this box up here says. It says that when velocity is positive, so where this thing is above the x-axis, it's advancing. So what I'm going to do here is write advancing, and where is it advancing from? Well, it's from, your time interval only goes from 0 to 8. Remember, this is not infinity to infinity. So it's advancing from 0 to 3. And let's see here. Since you're advancing the whole time, well, you know what? Let's just put parentheses around those. All right, so again, at 0, ding. And then 6 to 8. I would not put parentheses around those because technically at 0 you're not advancing, you're actually starting, right? The instantaneous rate of change at that would actually be 0. But we'll leave that alone. And then retreating happens when it's negative, so from 3 to 6. All right? And again, I would not touch 3 and 6 because it says strictly greater than or strictly less than. So no brackets anywhere. That point could be argued by others, but meh. Why? Compute the total distance traveled. Now total distance, over here we calculated, on the front we calculated displacement. Now displacement goes from where you start to where you stop. So in other words, if you went from Killeen, drove to Washington, D.C., and ended up back in Killeen, your displacement for your summer vacation would be 0. Meaning, as far as displacement goes, you didn't go anywhere. But for total distance traveled, obviously you know you'd have to add up Killeen to Washington, D.C., and then add up Washington, D.C. to Killeen. So we're going to do the same thing. So the total distance traveled here says you must calculate each distance between the turns